Hey folks, I am Pranay. I'm one of the co-founders at SigNoz. I'll be talking about ingesting huge number of events for our observability platform using OpenTelemetry and SigNoz. So let's get started. So here's a brief agenda of what I'll be discussing about. First, I'll give you a flavor of what's observability and why is it important. Then we will get into more details of OpenTelemetry, which is the instrumentation library we use at SigNoz to send data to our backend and then visualize it. And then I'll take you through the design and architecture of SigNoz so that you get a flavor of how our system is built and what could be the challenges which might be there in ingesting huge number of data points and how you overcome that, right? And in the process, we'll also discuss about how do you discuss and expand OpenTelemetry Collector, which is the main ingest component through which you ingest data. And then some more points about why columnar databases are interesting for observability data, right? So first of all, let's talk about what's observability, right? So observability, to define it, is the measure of how well a system can be inferred from the knowledge of its external outputs. So for example, if you're trying to understand how a person is by trying to understand what's the temperature is, right? So if you think about it, the temperature of a person is indication of something wrong which is going on with the person, right? And hence that is a reflection of what's being wrong. And we use tools like thermometer to understand why the temperature is high and to measure the temperature, and then that is used by doctors to infer what's wrong. So observability for computer systems and software systems is very similar. We try to measure the external symptoms of what's the users are experiencing to try to debug, to get a sense of if something is wrong, and through those systems trying to figure out what could be the potential root cause of it, right? So think about it like if a system has high latency, for example, if your web servers are taking a lot of time to respond to your users, what could be the reason behind it? So the high latency is a symptom, but the underlying cause is because some database query is taking more time, or some external APIs calls are taking more time, right? So that's broadly what observability is. Now, why is it more and more important to know, right? So one of the things which has happened in the recent, maybe last 2-3 years, is that more and more people are shifting to microservices. Earlier, it was the code bases were primarily monolith. You have a single big code which is running, and then in this case, you can easily print out the logs and try to understand what's going wrong, right? But if you have a microservices architecture, you don't have a single system on which you can print logs. There are different components of the system, and each components behave independently. And then to figure out what's wrong with the whole system, you're not sure which part do you measure, right? So as this graphic shows, in a monolith, you can just put a thermometer here and then get the sense of what's wrong. While here, there are like different subsystems, and then you're not sure where to put the thermometer to get a sense of what's wrong, right? And hence, we believe that as more and more systems are moving to microservices, observability systems will become more and more important, right? And that's one of the reasons why we started working on SigNoz. So if you think about it, there are primarily 3 pillars of observability. One is metrics, which is the aggregates of time series data points which you see, which shows how your systems are performing. For example, if you want to see latencies, so it's a time series graph of how the different latencies are there, and you get a sense that okay, in this time some latency has gone up or gone down. But fundamentally, it's an aggregate of your underlying metrics. Logs are important events which occur during the execution of the code. So if you're a developer, during the execution, you can add a certain statement in the code that, hey, something got printed or some function got executed. So when the function gets executed, you get a sense of what got printed, and like that step has passed. And traces are basically a complete request across the software stack. So just to give you a sense of like what does this look like, let me share a quick example of SigNoz. Yeah, so if you see this, these are like the different applications. These are the different metrics which I was talking about. For example, this graph is talking about application metrics, for example, P99. And you can see like different time series graphs which tell you the state of the application. And then you can go to like different traces, which shows you like how a particular request is spending its time in different parts of the microservices. So for example, this is a trace. This shows you complete stack trace of how a particular request which was made on this API went through like different services. For example, here it's going from dispatch endpoint to customer endpoint, then root endpoint, and then maybe other different microservices. Right? So you have lots of details on this, and you can try to figure out like what's going on, right? So these are like the two key pieces of observability, and of course the third piece is the logs. Right. So now we have a sense of like what is observability? Like, it helps you figure out what are the different parts of the system and if some issues happen, you can quickly figure out through these signals on what's going wrong, right? Let's not discuss about OpenTelemetry. So OpenTelemetry is a fairly recent project, and it's a collection of tools, APIs, and SDKs which help you generate this and collect and export this telemetry data, right? So we talked about like different type of telemetry data, which could be metrics, logs, and traces. So OpenTelemetry is the instrumentation, helps you instrument your applications with these, and then you can send it to OpenTelemetry Collector, and then you can export this telemetry data, and then you can use a backend, for example, like SigNoz, to visualize it and store it and like do more analysis on top of this, right? So OpenTelemetry is open standard, like a lot of top companies like Microsoft, AWS, etc. are contributing to it, and it's a fairly maturing project. So do have a look at it if you haven't had a chance to check out. And at SigNoz, we use OpenTelemetry underlying for instrumentation. So you can instrument your applications with OpenTelemetry and start sending data to SigNoz, and then SigNoz will help you visualize and understand what's going wrong with your systems, right? So some of the key features of OpenTelemetry are like it has all the three key pillars of observability we talked about. It has traces, it has metrics, it has logs. So you can create this telemetry data and also collect from your services. Like, so for example, if you're running a web server, you can instrument your web server to send traces, metrics, and logs, and then visualize the backend systems. It provides drop-in instrumentation, so it has lots of auto inject libraries which can for frameworks like Spring, ASP.NET Core, Express. So you can just inject these libraries in your code base and then start seeing data about it, right? And this is open source and vendor neutral. It is supported by lots of industry leaders, as I mentioned, like Microsoft, AWS, etc. And hence it's an effort from the community to make the instrumentation part of the observability open standard so that everybody can rely on it, and then you can use different tools to sort of visualize it, right? So that's where like OpenTelemetry fits in, and let us couple. So let's talk about OpenTelemetry Collector, which is sort of one of the key components of OpenTelemetry. Let me share a quick diagram. Maybe that would be more helpful for you. Yeah, so this is a good diagram which explains how the OpenTelemetry works. So this OpenTelemetry is something called collector, on which you can start sending data from your applications, and then you can visualize it through multiple metrics, right? So now OpenTelemetry Collector has three key pieces. It has something called it has something called receivers. It has something called receivers, which helps you receive metrics from different places, like your applications, or you can receive Prometheus metrics, and then you can process it. For example, you can process your OpenTelemetry, the metrics you receive through your applications, and then add more data to it. Like, for example, you can enrich with the node metrics, or you can maybe remove your sensitive data. You can create a processor to remove any sensitive data from the data you received, and then try to process it. And then it has exporters. For example, it can export to different databases. It can export to different backend systems, so that you can then visualize it later, right? So that's what OpenTelemetry Collector is. And we'll come back to this later, where we discuss more about like how this is important. But let me first give you a quick intro of what's like SigNoz, because we use OpenTelemetry heavily. So as of now, SigNoz is an open source observability platform. As of now, primarily focusing on the application monitoring, performance monitoring piece. So we are an open source APM. Currently, we have metrics and traces. And as I showed you in a quick demo, you can go from metrics to traces very quickly. We are soon also adding logs. We have very powerful tracing filtering functionalities. You can aggregate things very well. And the core principle which we have is to make it as easy as possible, right? So if you see other SaaS tools like Relic, DataDog, they let you set up systems very quickly. But most of the current open source systems are not as easy to set up, right? So one of the things which you want to do with SigNoz is set up as easily as possible. In just a few clicks, you should be able to start seeing your application metrics and visualize it in SigNoz, right? We use ClickHouse as the data store. It's a OLAP data store, columnar DB. And I'll also talk about later on why Columnar Database is important for observability data. And like being open source, you don't need to send data to any outside servers. You can run SigNoz in your cloud, right? So that's probably what we do at SigNoz. You can set it up very easily, get installed and run in your own cloud, right? Now let's take a quick look on like how we have designed SigNoz, and then this should lead to what could be the potential issues which may face, right, at ingesting in huge scale. So broadly, we use OpenTelemetry. We use OpenTelemetry libraries to instrument applications. So you can instrument your applications here. Add OpenTelemetry libraries. This goes to OpenTelemetry Collector, which receives all these libraries. And then you write to ClickHouse store, right, which is our main data store. And then the dashboards which you see, they call the Go backend, which is a query service, which talks to ClickHouse underlying, right? So that's probably the architecture. And so now let's talk about, come to the topic of like what could be issues which we face, and on like if you try to send huge amount of data through SigNoz and OpenTelemetry, right? So this is just a example which we came across when we were working with one of our users who was like sending huge amount of data to us, and then we wanted to test like what's the scale which SigNoz can handle, right? So that's when we started working on this and trying to really test the limits of what OpenTelemetry with SigNoz can handle, right? And what we found was really surprising, and that's what like I'm really excited to share with you. But to give you a quick sense, let's take a quick pause and try to see like where could be the issues, right? So yeah. Cool. So we just saw that, okay, so SigNoz has this architecture where like these are different applications from where you start sending data to OpenTelemetry. So say this is app 1, this is app 2. Now you're trying to send this data to this OpenTelemetry Collector, which comes with SigNoz, right? And then you try to send this to ClickHouse, which is our data store, right? Now there could be a couple of potential bottlenecks. So if you send, and the type of event scale which you're talking about, like 1 million events per second. So one bottle point could be this, that if your apps are sending huge amount of data to the hotel collector, there could be back pressure here. So lots of hotel collectors, like lots of data is being sent to this hotel collector. Is data getting dropped here, right? And then second piece is this, which is like if you send a lot of amount of data from hotel collector to ClickHouse, how much is it able to handle, right? So these were basically the two questions we wanted to test and see like where do we end up, right? Like, or how much scale is this being able to handle? And like couple of quick points about OpenTelemetry. So OpenTelemetry, the collector which we have is a statelet collector, so it can be scaled by increasing the number of replicas. So if you're using, for example, Kubernetes, you can add a lot of number of replicas to handle the scale, right? So that's like one of the good features of OpenTelemetry, that you can scale it horizontally and just like add multiple number of replicas to it. And yeah, let's discuss now about what could be the different hierarchy in which we can run OpenTelemetry Collector, right? So yeah, so let's let's see, like what could be the different hierarchy for OpenTelemetry Collector. So OpenTelemetry Collector can run in like 3 different modes primarily. One is a sidecar, 3 modes primarily. One is a sidecar mode where like sidecar mode. The second is it can run at each node, which is like the each VM. Or third is it can run on each cluster, right? So these are primary 3 modes in which OpenTelemetry Collector can run. Sidecar mode is nothing but you run OpenTelemetry alongside an application. Suppose you have a application 1, and by this I mean something like say a Spring Boot application, right? So you have a Spring Boot application, and then you want to collect metrics from it. So either you can, in sidecar mode, you can just add a hotel collector which can run here as sidecar. And then it will collect all metrics and then try to send to us third party, right? So the way this will work is like each application will have its own sidecar. Each application will have its own sidecar. And then maybe multiple if you want to send it to a particular bigger hotel collector or like main hotel collector, it will try to send to that, right? The issue with this approach is that there are like lots of hotel collectors and things, so it's difficult to manage. Also, like because each hotel collector needs certain resources to run, it takes lots of resources from the system, right? But the advantage is that it's like blast radius is very small. If one of the OpenTelemetry collectors goes down, only this OpenTelemetry collector goes down, right? The other approach could be you can run only on a single node. So rather than you running on like each collector, you don't run it here. You run a single collector on each node, which is like the way I'm here. And then you start sending metrics from here, right? So the advantage here is that you will get all VM metrics like memory users, CPU users, etc. You can get it here, which you couldn't have got here because you don't have a sense of what a VM is here. And then you can sort of send these metrics to here, right? Again, this has like a bit lower number of total collectors, so less number of fault points, but also like more compared to like if you run it single hotel collector, right? The other approach could be you can just like run a single hotel collector, and rather than each application sending to like their sidecar, you can just send directly to here. So no hotel collectors at the node level also, but just runs things, instrument all applications, have your applications, and then keep on sending it to the main cluster, right? So there can be different nodes. So this can be VM2, VM1, and each VM can be sending data, or like applications in each VM can be sending data to send data to a central hotel collector, which can be on the cluster level, right? So these are like different ways in which OpenTelemetry Collector can scale. You can either run it as sidecar with each applications, you can run it on node. This advantage that you get the infra metrics also, while here you can run it as cluster, right? So yeah, so this slide basically talks about how does these different model works, and let's talk about like what we worked on, right? So we worked on ingesting and trying to test this in a Docker swamp environment. So this was just a test. Ideally, we could have done it on a Kubernetes cluster, but this was just a test on handling how much resources can an OpenTelemetry collector handle, right? So we started generating data of around 1 million events per second. The amount of resources it took, so we had it in a single Docker swarm setup, and this was not a Kubernetes setup, so this was a single setup where you can you have a single virtual machine, which is like we used a 96 CPU or 72 CPU virtual machine. And then we used a 16 hotel collector replica set. So made 16 replicas for it, but a single VM instance, right? Single ClickHouse instance in the VM. So what we found was that this setup was able to handle like 1 million events per second, right? Which is quite huge, and which is what we're like very surprised with. And if you see broadly, this is at this scale, this resource utilization is very cost effective. Like you get a 42 vCPU machine in AWS at like very easily. Like you can get a 96 CPU intensive machine very easily, and then you can now ingest like 1 million events per second, right? The published benchmarks for hotel collector, like if you are not using any sampling, is for a 2 CPU 4 GB machine, it's like 20K events you can send. So broadly, if you see to send around 1 million events per second, you have to run around 50 replicas. While in our experience, we found that like 16 or 10 collectors were able to handle that scale. So that's around like 50 to 60,000 per events, but that also depends upon like the number of events which you are sending, and like maybe also the type of the events. But yeah, like so this is scaled decently well. We're able to send around 1 million events per second, handle it with just 16 replicas in the Docker Swarm container, and then the amount of CPUs we're using are like 42 CPUs, right? So this was like really surprising for us, that hey, like a single vanilla OpenTelemetry Collector installation with a single ClickHouse instance worked for handling this 1 million events per second, right? So this gives a lots of confidence to on how much OpenTelemetry can scale, and also like how ClickHouse is a good database for this. There are like possible improvements for which we can do, as I mentioned, between OpenTelemetry Collector to ClickHouse. We can have some sort of queuing engine. ClickHouse supports something called Kafka engine in-house. And then there's also concept of buffer engine. So maybe we can try to improve this by adding a collector. But like for the 1 million events per second scale, we are not seeing any such issues. If you want to have better performance for the ClickHouse is also both horizontally and vertically scalable. So you can scale ClickHouse horizontally using SARD. You can also set up data replication to enable redundancy. This might be useful for production, but for our case, we are just testing it on like what were the load limits, so we didn't really get into these things, but might be an useful exercise if you want to run this in production, right? And the third piece is you can also do a distributor setup of ClickHouse. So rather than having a single machine ClickHouse instance running, you can set up distributors so that a same query is like distributed among different instances, and then you can get data from different instances and then merge it back, right? So that might be in like some of the possible improvements which we think could be made. But even this result at like, even to test this result seems very interesting to us, that it was able to handle 1 million events per second without any issues, right? So yeah, and last point, like one of the questions that many people had was like, why did you choose to use a columnar database? To us, columnar database make natural sense for observability because you can add as many like rows and like attributes you want, and there's no prior schema which is needed. In observability, basically, if you want to provide good analytical capabilities like we do provide in SigNoz, aggregation of queries is very important, and this works pretty well for like aggregate for columnar database, right? And And so just to give you a sense of like why this is important, let me share a quick maybe example. Yeah, so just a quick example of on like why columnar databases is important. So generally for observability, especially in the application monitoring space, the type of data we deal with is like, for example, you're trying to trace a request across different systems, right? So you have a example like get, and then it's making query to, for example, this is the resource, get a string, and then there's like you have time, like time taken, operation, and this is the method name, and time taken, say 12 millisecond, and then say HTTP code, right? Say 200. So like, and then you can add different attributes here, right? So now suppose if you have different, so each request is like this. If you're storing this in like columnar database format, you can just do aggregate queries like, hey, tell me the average time taken by queries which has HTTP status code is equal to say 200, right? So what you have to do is you just have to say like find HTTP queries which has HTTP code this, and then just copy the, like try to get an average of this, right? So if you see, if you're storing these as like columns, you don't need to look into other columns at all. You can just say, hey, like what are the rows which has HTTP code is equal to 200, then you take the time for those and then just do an average of this. So this is just basic example of like why column-based data makes more sense, even especially if you're doing lots of aggregations, right? And this is where we think the real power of observability systems will come if you allow like users to slice and dice the data in different ways. And columnar database really seems very suitable for this, right? So and just to point out, and like if like all the required queries are in the same locality, it also increases query speed. There's a blog by Honeycomb also on why they chose a columnar database as the main data store, and do have a look at it. It's very interesting. Mentioned some great points there. So yeah, so that's broadly like what I was trying to convey, that hey, even with using OpenTelemetry and like a ClickHouse data store, which we use at SigNoz, we have been able to scale it to like 1 million events per second, which is like a huge scale and like good enough for many enterprises to work for, right? And the resource utilization are not very high. So of course, there are like many improvements which we can work on, but this shows like very encouraging signs on how these systems can be scaled and like how the next generation of observability tools would look like. Yeah, so that's probably where we are. If you're interested in the project, if you're probably interested in the observability domain, check out our repo. Do also check out our Slack community, hang out there. We have around 800 plus members there. And if you're interested in working on it, or working on the domain, we are always looking for good people to join our team. Do give me a ping. And yeah, or if you're interested in contributing to the project, just have a look at the issues, open issues, and then feel free to say hi. Cool. So that's all about me. These are my coordinates. If you want to have any other questions or discuss more about on what I've shared today, happy to listen to your thoughts. And yeah, thank you. Bye-bye.